Stars, those twinkling dots that decorate the night sky, begin their lives in nebulae, massive clouds of dust and gas. A particular region within a nebula, under the influence of gravity, starts to collapse. This collapse results in a dense, hot core called a protostar. As the protostar continues to gather more and more material, its temperature and pressure increase. When the pressure and temperature reach a critical point, nuclear fusion, the process that powers a star, begins. The protostar has now matured into a main sequence star, like our very own sun. Now, the star enters a delicate balancing act. The outward pressure produced by nuclear fusion counteracts the inward pull of gravity. This balance maintains the star's stability for millions, even billions of years. However, this equilibrium does not last forever. As a star exhausts its nuclear fuel, it can no longer maintain the pressure needed to counteract gravity. The core begins to contract under its own weight, and the star expands, becoming a red giant or a red supergiant, depending on its initial mass. For stars that are about the same mass as the Sun, the story ends here. Their outer layers drift away, leaving behind a white dwarf. But for more massive stars, the tale takes a different turn. As the core of a massive star contracts, it gets hotter and denser, igniting further stages of nuclear fusion. This fusion of heavier elements continues until the core starts producing iron. Iron, however, cannot fuel nuclear fusion, and the star's death knell begins to toll. The iron core collapses under gravity, triggering a violent explosion, a supernova. This explosion outshines an entire galaxy and ejects the star's outer layers into space. What remains is either a neutron star or, if the star was especially massive, a black hole. So, what have we learned today? We have explored the life cycle of a star, from its humble beginnings in a nebula to its grand finale as a supernova. We have understood how the delicate balance between gravity and nuclear fusion determines a star's fate. And we have seen how the death of a star can lead to the birth of a neutron star or a black hole. Remember, every star you see in the night sky is on this cosmic journey. Some of them might have already met their explosive end, but their light is yet to reach us. So the next time you gaze at the stars, think about their life stories. After all, as Carl Sagan once said, we are all made of star stuff.